In this video, we'll learn about server-side rendering single-page JavaScript apps, which are also known as isomorphic or universal apps. We'll investigate the difference between client-side rendered and server-side rendered applications. We'll then learn about the benefits of server-side rendering, followed by a conceptual look at implementing SSR with React. Let's begin. A single-page application, such as the ones we build using React, are typically client-side rendered apps. You send a request to the server, and the server responds back with a single HTML document, along with a couple of JavaScript files and a style sheet. Once this package is downloaded in full, your browser executes the JavaScript code, and the app runs in your browser. Thereafter, if the app wishes to fetch some data from the server or some other API service, it will do so using HTTP requests as and when needed. Otherwise, your app runs completely in the browser. This means your app is snappy and offers a fantastic user experience. But let's not jump to conclusions. You see, you still have to wait for the JavaScript app bundle to download in full before you see the app in action. On a slow network, this translates to a blank white page until there is a minimum viable app code to run. This can lead to a bad user experience. The second problem relates to search engine optimization and content indexing by crawlers and search engines. I mentioned earlier that React apps are inherently client-side rendered. This means that if you look at the contents of the page in the browser, there's nothing to see because the content is rendered on the client and is purely dependent on the execution of the React app in the browser. As an illustration, let's understand how Google indexes a client-side rendered React app. Google first crawls through the HTML page that the server will send back. This process is termed as a wave. Since this contains no actual content to index, except a root div and script tags with reference to React code, Google understands that you have a JavaScript single-page app at hand. Now, rendering such an app and waiting for data is a time-consuming and resource-intensive process. So Google defers and puts the execution of the client-side app on the back burner until it has available resources to execute the app and assess if it can be indexed. This delay can run into days at times. Whenever the next opportunity arrives, Google will attempt to execute your app code and perform another pass or a wave, and even then, there is no assurance that the contents of your app would indeed be relevant enough to be indexed as desired. If your React app offers dynamic content such as news, which changes every day, then you cannot expect Google to continually index content offered by your client-side rendered app. The fact that Google does consider client-side JavaScript apps now is a major step forward in search engine crawlers. Just a few years back, this wasn't possible at all. But it is not efficient and cannot be relied on. The first preference even today is given to content that is readily available, rendered on the server, so that when a crawler visits your site, the server sends back HTML with the actual content and not a markup to load a JavaScript application. In fact, that is how the internet was back in the old days. Your content was always rendered on the server before it reached your browser. So, should we go back to building sites the Stone Age way? Thankfully, we don't need to. What we need to do instead is find a middle ground, a way to render your client-side application on the server with an initial set of data. This way, the HTML that the server sends back contains a rendered version of the application with an initial set of data. This means a visitor will instantly get to see your app in the browser. Meanwhile, our original client-side app would be downloaded asynchronously in the background, and we could seamlessly switch over to this snappier version so that we continue to offer that awesome user experience that our client-side rendered app promises. This workflow would offer the best of both the worlds. To the user, an instantly visible UI means no blank white pages while the JavaScript app loads up. To the search engine crawler such as Google, it means pure server-side rendered content to index right away, just like the old days. This technique is known as server-side rendering, and apps that offer this capability are typically known as isomorphic or universal apps. Besides being the perfect solution for SEO and crawlers and offering a great user experience, isomorphic apps are also a great choice when your web app is consumed on mobile devices with unreliable network connectivity. The server-rendered UI means your user gets to see your app quickly since we've delegated the task of rendering the app to the server. For fringe cases where a device is unable to execute JavaScript, your user won't see a blank page, but will instead see a minimal version of the app that shows actual content. So, how exactly does server-side rendering work? First, the server sends a rendered static version of the React app. This is the same React app that will run on the client. The browser uses this to render the page, and the user can now see the app in the browser instead of a blank white page. This is your server-side rendered app in action. But you cannot interact with this app just yet, because interactivity and dynamism are the job of your React JavaScript app, and so far we have just rendered static HTML markup. The browser then executes your React app using the app bundle downloaded in the background, which then hooks onto the server rendered content and brings it to life with interactivity. Technically speaking, the JavaScript app hydrates the static markup and takes over operations. This shift is seamless. To serve the server-rendered React app, you typically use a Node.js server such as the ones built using the Express framework. React offers us tools to render an app as static HTML markup. Using these tools, our Node.js app running on the server can render the HTML for the React app and send it to the requesting user. The React DOM library, for instance, offers us the render-to-string function, which renders an HTML version of React components. On the other hand, our client-side version of the app should then hook onto this static HTML in the browser and hydrate the app, restoring interactivity and dynamic behavior. This is achieved using the hydrate function from the React DOM library. So instead of calling the usual React DOM.render, we will call React DOM.hydrate instead. A combination of render to string and the hydrate function allows us to convert our client-side rendered app to an isomorphic server-side rendered application that offers the best of both the worlds. Now, usually we have been building apps using the Create React App toolchain, but when building isomorphic app, this toolchain will not work for us because it is designed to produce client-side rendered apps only. Thus, there are two ways to build server-side rendered or isomorphic React apps. You can use Webpack and Babel to create a custom toolchain that allows you to produce isomorphic React code comprising of client-side and server-side editions of your React app, including a Node.js-based server. The second way is to use a framework like Next.js, which is designed to let you build isomorphic React apps quickly and easily. The choice depends on the project at hand, but Next.js is most certainly a battle-tested and safe bet in this case. You should definitely implement server-side rendering when your app needs to be SEO compatible and when your app bundles are big and take time to download. In such situations, a server-side rendered React app would be the perfect solution.